Welcome back to Devtern. In this video, we'll be exploring the development and implementation of a hand gesture brightness control project using Python. We'll be delving into the code and providing a step-by-step guide to bring this innovative project to life. Let's get started. Code explanation. Now, let's go through the code line by line and understand what each part does. Step 1. Import all required libraries. We'll start by importing our necessary libraries. 1. Import CV2. CV2, this is the OpenCV library, which is widely used for computer vision tasks such as image processing, video capture, and analysis. It provides tools for real-time image and video processing. 2. Import MediaPipe as MP. MediaPipe is a cross-platform library developed by Google that provides solutions for various machine learning tasks, especially in the domain of computer vision, such as face detection, hand tracking, and pose estimation. As MP, this renames the MediaPipe module to MP to make it easier to reference in the code. 3. From Math Import Hyport. Math, this is a standard Python library for mathematical functions. Hyport, this function from the math module returns the Euclidean norm, x2, y2. It is useful for calculating the distance between 2 points in a 2D space. 4. Import screen_brightness_control as SPC. Screen_brightness_control, this is a third-party library that allows you to control the screen brightness of your computer programmatically. As SPC, this renames the screen_brightness_control module to SPC for ease of use. 5. Import NumPy as NP. NumPy, this is a fundamental package for scientific computing in Python. It provides support for large multidimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. As NP, this renames the NumPy module to NP to make it easier to reference in the code. Summary. CV2 OpenCV library for computer vision tasks. MediaPipe library for machine learning solutions in computer vision. Hyport function to calculate the Euclidean distance between 2 points. SPC screen brightness control library. NumPy library for numerical operations on large arrays and matrices. These imports suggest that the script will perform tasks involving computer vision, machine learning, mathematical calculations, and possibly controlling screen brightness based on some visual or numerical inputs. Step 2. Initializing hands model. Let us look into the parameters for the hands model. Hands static_image_mode equal to false, model_complexity equal to 1 min_detection_confidence equal to 0.75, min_tracking_confidence equal to 0.75, max_num_hands equal to 2. Where static_image_mode, it is used to specify whether the input image must be static images or as a video stream. The default value is false. Model_complexity of the hand landmark model 0 or 1. Landmark accuracy as well as inference latency generally go up with the model complexity, default to 1. Min_detection_confidence, it is used to specify the minimum confidence value with which the detection from the person detection model needs to be considered as successful. Can specify a value in 0.0, 1.0. The default value is 0.5. Tracking_confidence, it is used to specify the minimum confidence value with which the detection from the landmark tracking model must be considered as successful. Can specify a value in 0.0, 1.0. The default value is 0.5. Max_num_hands, maximum number of hands to detect. Default it is 2. Summary. MFAN is a reference to the MediaPipe hands module. Hands, an instance of the hands model with specified parameters for real-time hand detection and tracking. Draw a reference to the MediaPipe drawing utilities for visualizing the hand landmarks and connections. This code sets up the hand detection and tracking model from MediaPipe, configuring it to handle video input, and defines the parameters for detection confidence, tracking confidence, and the maximum number of hands to track. The drawing utilities are also prepared for visualizing the results. Step 3, process the image and apply brightness based on the distance between thumb and index fingertip. Capture the frames continuously from the camera using OpenCV and convert BGR image to an RGB image and make predictions using initialized hands model. Prediction made by the model is saved in the results variable from which we can access landmarks using results.multi_hand_landmarks, and if hands are present in the frame, detect hand landmarks. After that, calculate the distance between thumb tip and index fingertip. Map the distance of thumb tip and index fingertip with brightness range, i.e., according to distance between them, brightness of system will change. Let's break down the code for capturing video from a webcam and processing it for hand detection and brightness control. 1. Start capturing video from webcam. Cap cv2.videoCapture0. cv2.videoCapture0. This initializes video capture from the default webcam. The argument 0 refers to the default camera device. If you have multiple cameras, you can change the number to select a different one. 2. Continuous frame capture and processing. While true, this creates an infinite loop to continuously capture and process video frames until a break condition is met. 3. Read video frame by frame. FrameCap.read. Cap.read captures a single frame from the webcam. The cap.read function returns a Boolean underscore indicating if the frame was successfully captured and the frame itself framed. 4. Flip image. Frame cv2.flip frame 1. cv2.flip frame 1 flips the frame horizontally. This is often done to create a mirror effect, making the display more intuitive for the user. 5. Convert BGR image to RGB image. cv2.cvt color frame cv2.color_bgr to RGB converts the frame from BGR color space used by OpenCV to RGB color space used by MediaPipe. 6. Process the RGB image. Hands.processFrameD processes the RGB frame using the MediaPipe hands model to detect and track hand landmarks. 7. Initialize landmark list. Landmark list an empty list to store the coordinates of detected hand landmarks. 8. Check for hand presence. Process.multi_hand_landmarks checks if any hand landmarks are detected in the frame. 9. Detect hand landmarks. For handerman, process.multi_hand_landmarks iterates over each detected hand. For _ID, landmarks in enumerate handem.landmark iterates over each landmark in the detected hand. Height, width, color_channels frame.shape gets the dimensions of the frame. X, Y int landmarks.x width, int landmarks.y height calculates the pixel coordinates of the landmark. Landmark list.append_id, xy appends the landmark ID and its coordinates to the landmark list. 10. Draw landmarks. Draw.draw_landmarks frame handem emfans.hand_connections draws the landmarks and connections on the frame using the MediaPipe drawing utilities. 11. Process landmark list. If landmark list checks if any landmarks were detected. X_1, Y_1 landmark list 4.1, landmark list 4.2 gets the coordinates of the tip of the thumb. X_2, Y_2 landmark list 8.1, landmark list 8.2 gets the coordinates of the tip of the index finger. 12. Draw circles and line. cv2.circleFrame X_1, Y_170, 255, 0, cv2.fill draws a fill circle at the tip of the thumb. CV2.circleFrame x underscore 2 y underscore 2 70255 0 CV2.fill draws a filled circle at the tip of the index finger. CV2.lineFrame x underscore 1 y underscore 1 x underscore 2 y underscore 2 y underscore 255 03 draws a line between the tips of the thumb and index finger. 13. Calculate distance and set brightness. L hypot x underscore 2x underscore 1 y underscore 2 underscore 1 calculates the Euclidean distance between the thumb and index fingertips. B underscore level np.interpol 15 220 0 100 interpolates the distance to a brightness level between 0 and 100. spc.set underscore brightness in B underscore level sets the screen brightness to the calculated level. 14. Display video and break on cue. CV2.imShow image frame displays the processed frame in a window titled image. If CV2.wake key 10x afford QB, ATA checks if the Q key is pressed. If so, it breaks the loop and exits the program. This code continuously captures video from the webcam, detects hand landmarks, and controls the screen brightness based on the distance between the thumb and index finger. It also provides visual feedback by drawing landmarks, circles, and lines on the detected hand. All right, time to put our code to the test. Let's run it and see what happens. That's all for this video. I hope you enjoyed learning about hand gesture brightness control with Python. If you did, give this video a thumbs up and consider subscribing for more coding adventures on Devtern. Happy coding!